Hi guys, this is Saurav here and welcome to another session for the Chemical Kinetics lecture. This is lecture 5 and we are currently discussing first order kinetics. And very sorry for this late start. Physics class abhi khatam hui hai. And so it took us some time for start the session. This is like the lecture 2 on first order kinetics and first order ab usko first order reactions bol lo. And we have already done the basics of first order reactions. We have identified some inferences, primarily half-life and T75%, T87.5%, what to do to identify what is the time the reaction takes to go on to completion. Okay, and there are some other inferences that we have to identify, and we will be doing it simultaneously. I'll be doing it, you'll be doing it. So I would request you guys to sit with a pen and a paper because these involve simple mathematical manipulations. So बहुत simple, we are not going to do numericals kind of questions, but what will happen in examinations, they will just give these expressions, these informations, and they'll put that thing in a question. Okay, so hello Preetam, hello Anit, hello Ajay, hello Zaki Anwar. So a very warm welcome to everybody and happy Ganesh Chaturthi. Okay, Ganpati Bappa aapko whatever you dream of, he just blesses you with that, and may you achieve everything that you want to. Okay, like, share and subscribe, that's always the motto. And we are currently doing this. मैंने आपको बोला था कि ये blue तब होगा जब हम completely इसको खत्म कर देंगे. Okay, चलिए. So let's start today's session. And let's start today's session with the first idea that we have to decide a certain inference which is dependent on this information. Okay, which is dependent on this information. If the initial concentration is not known, but the amount of reactant left at end of a certain time can be expressed as a fraction of initial concentration. Let's say initial concentration मुझे पता नहीं है. What is the expression that I would use to calculate the rate constant? Okay, because everything depends or revolves around the rate constant. So देखिए इसको how should it be done? So what I'm saying is that A is unknown. A is unknown, but what is given that the amount of reactant left can be expressed as a fraction of the initial concentration. So what is the amount of reactant left? Reactant left हम क्या बोलते हैं is equal to A minus X, isn't it? We say that reactant left is equal to A minus X. The amount of reactant left at the end of a certain time is expressed as a fraction of initial concentration. Let's say this is some phi times A, where phi represents a fraction, Okay, so can I say that the expression for this rate constant 2.303 upon T log of A by A minus X can be written as 2.303 upon T log of A by phi A. Okay, can I do that? A is unknown. Let's say A is unknown. मैं just A लिख देता हूँ यहाँ पे. And amount of reactant left, that is A minus X, is phi A. So A, phi A gets cancelled. Our expression becomes K is equal to 2.303 upon T log of 1 by phi. Okay, this is the new expression that you would be getting if this information is given. Okay, so don't worry if you are not given the initial concentration. There could be a number of different ways the question can be formulated so that you get the value of rate constant. Okay, you can get the value of rate constant. Clear? Very simple. Let's So everybody, if has solved this, please take a note of this, please take a screenshot of this. We'll move on to the next inference. Okay, so the inference is K is equal to 2.303 by T log of 1 by 5. Now let's say it is 50% of the reaction. Okay, let's say it is 50% of the reaction. So if it is 50% of the reaction, then the value of phi will become, if it is 50%, then phi will become 0.5. Okay, phi can be 0.75, phi can be 0.875, phi can be 0.95. If it is like 50% reaction, 75% reaction, 87.5% reaction, and 95% reaction. Okay, so if 50% reaction, that means half-life, you put the value as 0.5, you get a expression for K. If it is 75%, you put the value of phi as 0.75 and you get the value of K. Okay, you get an expression for K. Clear? So we will move ahead from here. This expression is pretty simple. Okay, the next thing is this. Many a times it happens that the reaction is not taking place in aqueous medium. Okay, usually when reaction takes place in aqueous medium, we take number of moles by volume to identify concentration. But if the reaction is not taking place in aqueous medium and the reaction is gaseous, if the reaction is gaseous, then the pressure or the partial pressure of each component can be utilized as their concentration. So how can we work on this? Let's say if P needs to be calculated, I hope you know this, PV is equal to nRT. Okay, so in a closed container, can I say that P nRT by V is constant? In a closed container, V is constant, so P becomes directly proportional to the number of moles. So even if number of moles is not given, it's not a problem. You can utilize only pressure to calculate the expression for the first order reaction. Okay? Can we take Bhumika? Number of moles is not given. You are given, see, if the reactants as well as products are gaseous, for a reaction A changing to B plus C, you are given pressures, you are not given moles. Okay, you are not given moles. If moles are not given, अभी तक आपने क्या किया कि moles आपने use किया है. But if you are not using moles and you are given pressure, how should you use pressure? Clear? So let's see how can we use this. तो हमारे पास क्या दिया गया है? Okay, let me just. Okay. So the information that is given to us is the partial pressure of A. देखिए क्या दिया गया है? Partial pressure of A. So let's say the reaction takes place like this. A changes to B plus C. Okay, A changes to, yeah, शिव गैस के लिए सिर्फ प्रेशर यूज करते हैं. Time equals to 0, time equals to T, and time equals to infinity. Let's say you are given two informations that the pressure of A at 0 is P naught, and this is 0 and 0, and pressure at time T is given as PT. Okay, time T pressure is given as PT. Now at time T, can I write this as P naught minus X, and this is X and this is X? क्या लिख सकते हैं इसको? At time T, I have to use this information. At 0 pressure, the pressure due to A is P naught. At time T, I will write that P naught will disintegrate to a certain extent X, और मैं x लिखने की जगह मैं स्मॉल p लिख देता हूं, या फिर x ही रहने दो इसको, so that doesn't create confusion. So p naught minus x. So what is the information? can I say from this that PT is equal to P naught minus X? Can I say this? PT is equal to P naught minus X because it is given that the pressure of A at time T is PT. And what is PT equal to? P naught minus X. Okay, P naught minus X. Clear? Now if PT is equal to P naught minus X, can I write X is equal to PT minus P naught? Sorry, X will be written as P naught minus PT. Yes, clear? Now what is the equation? K is equal to 2.303 upon T log of A upon A minus X. 2.303 log of A upon A minus X. Now what can I write for A? A क्या हो जाएगा? Initial. What is A? Initial. And what is X? P naught minus PT. So I will incorporate those values and my expression will become something like this. 2.303 upon T log of P naught by P naught minus P naught minus PT. Isn't it? Isn't it? This will, so if I take X on this side and it on this side, this will be the expression. So what is the final expression? What will be the final expression? The final expression will be this. K will be equal to 2.303 upon T log of P naught by P naught minus P naught will get cancelled out. P naught, Preetham, please do check your calculation. So this is P naught minus PT. So P naught and P naught will get cancelled out and I will get PT over here. Okay, ये आ जाएगा एक्सप्रेशन यार, ठीक है? प्लीज डू चेक इट. सो एक्स PT is equal to P naught minus X, or X can be written as, if I take X on this side, it will be written as P naught minus PT. If I incorporate this over here, so P naught by P naught minus PT, so P naught will get cancelled. I will have only PT over here. What? X is PT minus P naught? How it is X is PT minus P naught? Check कर लो यार. It's not PT. PT is equal to P naught minus X. Okay. Why do you need to take anti-log? Why do you need to take anti-log? There is no need to take anti-log over here. There is absolutely no need to take anti-log over here. So this is the right expression. Okay. Simple expression. Preetham, you have made a small mistake. Okay. Is that clear? So this is how do we use this information to calculate or get an expression for K. Okay. Chali. Have you understood this? Have you understood this? This is a very easy way of not getting scared in examination. Okay. So if you are given this information, just use the information in this manner. Just form the equation. Next question is, next inference that we need to identify is for this. You are given an inference that if the reactant as well as the products are gaseous for this reaction, A plus A changes to B plus C, it is given that total pressure, guys, it is given total pressure. It is not pressure of A. It is not pressure of A. Okay? It is given total pressure. It is given as total pressure. is given as P naught at 0 time, and at some t time it is given as Pt. Okay, so how do we use this relation? A changes to B plus C. A changes to B plus C at time 0, at time t. Okay, at time 0 and at time t. क्या लिख देंगे इसको? P naught. What is the total pressure initially? What is the, so we have to calculate, we are writing in terms of partial pressure, Rima. So this will be written as 0 and 0, and now it will become P naught minus x. This will be x and this will be x, isn't it? Okay, it will come like this. Now it is given that total pressure initially is P naught. Total pressure initially is P naught. Now initially what is present? Only reactant. So whatever pressure is, this is nothing but pressure of A. Pressure of A. Okay, if it is this is nothing but pressure of A. Now at time t, what I will write, total pressure is equal to Pt. So that means pressure of A plus pressure of B plus pressure of C initially is P naught. Pressure of A plus pressure of B plus pressure of C is equal to P naught plus x. Very good. P naught plus x, which is equal to Pt. Okay, and this is nothing but P of A. Are you so we write equilibrium constant in terms of pressure. This is not equilibrium, this rate constant, not equilibrium constant. Okay, I hope this is understood by everybody. A very simple expression. So we are getting these two inferences. I have to use these two inferences. So I have to use these two inferences. So can I say that x becomes equal to Pt minus P naught? Pt minus P naught. Now if I use the expression for K, so K is 2.303 upon T log of A upon A minus X. Okay, what is A, which is P naught? 2.303 upon T log of P naught divided by P naught minus X, A minus X, and X is Pt minus P naught. Now whatever Preetham had calculated earlier will come. Okay, what we would get is something like this. This will give 2.303 upon T log of P naught by 2 P naught minus Pt. So this is our expression for K under this given situation. Okay, so given situation, on the basis of the given situation, you will very, very carefully utilize the values of pressure. Okay, you will very, very utilize carefully the values of pressure, because pressures can be given for any damn thing. They can measure pressure for anything and they can give you in the question, and using that information you have to get the value of K. Okay, अरे शिव, उस केस में ये चीज क्या थी? वो वाले केस में, अरे what was the difference? In the previous case, this information was pressure of A. In this case, this is total pressure. Okay, is that understood? Pt is an expression. पिछले केस में this thing what was written over here was pressure of A. Now the information that they are giving you is total pressure. Are you able to understand? ये एक्सप्रेशन देख लो, ये एक्सप्रेशन देख लिया आपने? चलो इसको हटाते हैं, पिछले वाला क्वेश्चन देखते हैं. Previous question, this was partial pressure of A. The information given was partial pressure of A. Now the information given is total pressure. Now the information given is total pressure. Absolutely different informations. Absolutely different informations. The expressions, however, remain the same. Okay? Clear? Chalo. Have you understood this? Let's take another scenario. So they are different scenarios. So I'm taking different. In one case, I'm only giving you information about reactant. In one case, I'm giving you information about the total pressure. Let's take another scenario. Okay? Let's take another scenario. If the reactant as well as the products are gaseous for this reaction, now look at the information which is given. You are not given any information about what is happening at initial condition. Okay? You are not given any information about initial condition. You are given information about a certain time t and at infinite time. Okay? Entirely different information is given. You are given information about a certain time t and at infinite time. Okay? So, and you are given partial pressure of A, B and C. Clear? So, let's work out this question. बहुत simple सा है. हमको करना क्या है? I just have to form an equation. I have to understand that what does this PT refer to? What does this P infinity refer to? Okay? So, if I take reaction as A changing into B plus C, okay? Let's say initial pressure, let's say the initial pressure was P. Assume that initial pressure was P. Pressure at certain time is given, pressure at certain time, infinity is given. Okay? It is P, this is 0 and this is 0. Clear? Now I will write this as P minus X and this will be written as X and this will be written as X. Clear? This will be written as minus X, this will be written as X, this will be written as X. Okay, now if there is a number, assume that the question is given as A changes to 2B, so you will put 2 over here. But since the question does not have that, I will not worry about that thing right now. Okay? At infinite time, the reaction is completely over. What is the meaning of infinity? This will become 0. This will become 0 and this will become P and this will become P. Clear? At infinite time, the reactant will become completely 0. Okay? Reactant will become completely 0 and what would happen is X will become P. So I will put the value of X as P, X as P. Clear? Reactant becomes 0. Now let's use the information. What is given? That the sum of these three pressures, is equal to PT. Okay? The sum of these three pressures is equal to PT, which can be written as equal to P plus X. I can write this thing as P plus X. And the sum of these three pressures at infinite time is given as P infinity, which can be written as 2P. Can I write this? At P infinity, the sum of these three pressures is equal to 2P because this becomes 0 and this is P and this is P. Okay? No man, that is wrong. PT will become equal to P plus X. Okay? So this is very, very simple expression. अब इसको हमको solve कैसे करना है? बस simple maths use करना है. X will be, what will be P equal to? P infinity by 2. P will be equal to P infinity by 2. I will put the value of P infinity over here and get the value of X. So X will be equal to PT minus P infinity by 2, and initial pressure was P, What was the initial pressure? P. P is equal to P infinity by 2. Okay, P infinity by 2. I now have to use these two informations for identifying the expression for rate constant. What I'll write? K is equal to 2.303 by T log of A upon A minus X. What is A? What is A? A is nothing but P. And what is P in terms of the information which is given? 2.303 by T log of P infinity by 2. Okay? And this will also be written as P infinity by 2 minus what is X? Pt minus P infinity by 2. अरे A और X क्या है? A तो मैंने बता दिया ना, A is P. Okay? Product by 0 will become at infinity. No, that's not match. Whatever you're doing is incorrect. Okay? You are calculating it for equilibrium constant, but this is for rate constant. Okay? 2.303 is multiplied so as to get it to log base 10. Clear? So I will get this, and P infinity plus P infinity by 2 will become P infinity by 2 plus P infinity by 2 will become P infinity. So this expression will become, our final expression would be K is equal to 2.303 upon T log of P infinity by 2 P you always have to get the value of K. X कैसे आया? अरे X तो निकाल दिया हमने शिव. Is 2.303 जनरली कांस्टेंट? जनरली कांस्टेंट क्या? नंबर है, नंबर तो कांस्टेंट ही रहता है, नंबर थोड़ी चेंज करते हैं. अरे शिव, go in the backward direction. P minus X plus X. P minus X was pressure of A plus pressure of B plus pressure of C was given as PT. ये दिया गया था ना? And P plus P becomes P infinity. So I eliminate the value of P from here and place it in this equation. I get the value of X. यही तो है. ठीक है? Is that understood? I mean, does it change with conditions like temperature and pressure? Man, Atharv, no, dude. Rima, 2P is equal to P infinity. So what is P infinity? What is P equal to? P infinity by 2. P is equal to P infinity by 2. I put the value over here. You are given P infinity by 2. You put the value of P infinity by 2 over here. Plus X is equal to PT. Okay. So you'll get this expression. So my objective is always, अरे मैथ्स है, सिंपल मैथ्स है यार, सॉल्व करने की कोशिश कीजिए. Okay, try to solve this very simply. Like try to do it in a piece of paper. ठीक है? Let's move on to the next question. Okay, next inference. So this is our objective is to always use these informations to calculate the value of K. Okay. Next, if the reactant as well as products are gaseous, okay, अभी भी वही चल रहा है. What is given? What information is given over here? What information is given over here? Clear? Okay. What is the information which is given over here? The information that is given over here is total pressure of B and C. Guys, what you are doing is, आप लोग ये देखते हो, and you are not looking at what is the condition given. Okay, what is the condition given? Total pressure of B and C is given. See how many ways question can be formed, can be identified by these inferences. Clear? So you write this, A changes to B plus C. Okay, let's say I write this as T, time equals to 0, time equals to T, time equals to infinity. Okay, I write this as P. This will be 0 and 0 initially. This will be 0 and 0 initially. Man, Atharv, it is the conversion of ln log base E to log base 10. Okay, log base E to log base 10. It does not depend on टेम्परेचर एंड प्रेशर. लॉग बेस ई को लॉग बेस 10 पे कन्वर्ट करोगे तो वो टेम्परेचर एंड प्रेशर पे नहीं होता है. ओके, इट डज नॉट डिपेंड ऑन टेम्परेचर एंड प्रेशर. क्लियर? नाउ एट टाइम टी इट विल बी रिटन एज पी माइनस एक्स एंड दिस विल बी एक्स एंड दिस विल बी एक्स, एंड एट टाइम इंफिनिटी दिस विल बिकम 0 and this will become P and this will become P. Okay, this will become P and this will become P. See, first form this equation and then use this relation. Then use this relation and this piece of information. Okay. Now what is given? What is the information given? Pressure of B plus C is being only equated. I calculate the pressure of B and C and say that it is PT. Okay. I calculate the pressure of B plus C at time T and say that it is equal to PT. So if I use that information, then pressure of B plus C at time T, pressure of B plus pressure of C at time T is PT. What is the pressure of B and C? Okay, what is the pressure of B and C? X plus X, which will be equal to PT. Can I say this? X will be 2x will be equal to PT. This is one relation. Okay, 2x is equal to PT, and the second inference that I have is at time infinity. Infinity पे क्या हो जाएगा? टोटल प्रेशर B plus C का 2P is equal to P infinity. 2P is equal to P infinity. So can I say P infinity will be equal to, or nothing, P will be equal to P infinity by 2. What is P? P is nothing but synonymous to A. What is P? P is nothing but synonymous to A. A जो initial concentration के बराबर है. And what is X? PT by 2. Okay, आपको मैंने A दे दिया. I have given you X. You just need to form the equation. ठीक है? So K will be equal to 2.303 upon T log of A by A minus X. What will I put the value of A as? 2.303 upon T log of, what is A? P infinity by 2. And this will be P infinity by 2 minus PT by 2. This will get cancelled. Our expression will be our expression will be, क्या हो जाएगा हमारा expression? K will become equal to 2.303 by T log of P infinity by P infinity minus PT. ओके, ये हो जाएगा हमारा एक्सप्रेशन. दिस इज आवर एक्सप्रेशन. ओके, अरे ये भी आसान था, इससे पहले वाले भी आसान थे, सारे क्वेश्चंस आसान ही हैं. यू आर जस्ट नॉट लुकिंग एट दिस इंफॉर्मेशन. ये इंफॉर्मेशन सिर्फ चेंज कर रहा है. This information is changing, this part is changing, this part is changing. बस उसी को देखना है ध्यान पे. And whatever information is given, you have to somehow identify A and X using this. You have to somehow A and X using this. Okay? Last point यही था कि what I will do is A by A minus X है. A I have given you. What is A? This. What is X? This. Okay? यार always कुछ नहीं होता है. You have to look for change, and your mind should be trained in such a manner that you are always able to understand what is that change which is occurring. Okay? You have to keep your eyes and ears open. See, Babu, you will be given question in any form, any manner. I have just explained you the inference that how I am getting this. Okay, it will be way too lengthy in examination, but what you can do is you can practice these inferences over and over again, and depending on what is the language of the question, you can use one of them. Okay, you do not have to remember it, you have to just understand how are we arriving at it. Okay, how are we arriving at it? So let's say the information is given for total pressure of B and C. Now आपको क्या लगेगा कि you are just not getting the point that how I can calculate K if initial concentration is not given. So it is not important that the initial concentration should be given. Initial concentration may not be given, and yet you can calculate the value of K. That is what I am trying to prove from here. Okay, so next inference, if it is for this and it is only given for total pressure of B, Atharv, the value of the constant K is constant at a particular temperature. Okay, it does change if the temperature changes. So now it is given only for pressure of B. Only for pressure of B. एक तरह से ये फॉर्मूले हैं, आपके पास एक ही फॉर्मूला है एंड डिफरेंट इंफॉर्मेशन को आप उस फॉर्मूला में पुट करते जा रहे हो. फॉर एग्जाम्पल, यू आर गिवन मल्टीपल इक्वेशंस and you try to modify each and every one of those equations into an equation so that it resembles equation of a straight line, so that you want to plot a graph. Okay, how would you do that? You will use this mathematical manipulation. So pressure of, so again A changes to B plus C. This will P0 0, time equals to 0, time equals to T, time equals to infinity. Clear? This is P minus X, this is X, this is X, this is 0, this is P, and this is P. Now what information is given? Pressure of B. तो हमारे पास दो results आएंगे. What do I need? I need A and I need X. Okay? I need A and I need X. What is X? What is given at time T? What is the pressure of B? So at time T, pressure of B is PT, which is nothing but equal to X, which is nothing but equal to X. And at time infinity, pressure of B is given as P infinity, which is nothing but P. यही हो जाएगा. Okay. What is P? P is the same as A. So now I can write the equation. So K will be equal to 2.303 by T log of A by A minus X. A is given as P minus with A by A minus X. So 2.303 upon T log of what is A? A is the same as P, and P is the same as P infinity minus PT. You'll get this. Okay, so आपके पास क्या information आएगा I can't say, but whatever information is given to you, whether you are given pressure of one gas, pressure of all the gases, pressure of any two gases, you can always calculate or get an expression for K. Okay? Yeah, obviously. You do not try to remember this. If you try to remember this, that will be a very, very difficult thing. Okay? Please don't do that. 2 PT क्यों होगा? How would be 2 PT? Why would it be 2 PT? According to, yeah, obviously, Ritik. Okay? Obviously, I'll explain that. Okay? So, that finishes us with the first order reaction. We had about 10 inferences, and we'll start with second order reaction. Now, second order reaction is very simple. Second order reaction, a lot of people try to learn it in two different ways. Now remember that a second order reaction can be written in two possible manner. I can have a second order reaction which looks like this. लिख सकते हैं? I can have a second order reaction which is like this. So this is type 1. So can I say that there is a second order reaction which will look like this? Okay. There is a type 2 kind of a second order reaction. So what is the type A kind of second order reaction? A type A kind of a second order reaction is one which has only one reactant. Only one reactant. Type 1 means only one reactant. Only one reactant. If we have only one reactant, I have this expression. For this expression, I will write dx by dt is equal to k a minus x to the power 2 isn't it? I will write it like this. I'll have to integrate, solve this and get the answer. Okay? Now, type 2, the second type of second order reaction. The second type of second order reaction is one which uses two reactants. It has only one reactant. The second type of second order reaction uses two reactants. So it uses A and B to form products. Okay? And for this reaction, I will write rate as proportional to concentration of A to the power 1, B to the power 1. So two very simple expressions. I will get A plus B give rise to products and 2A gives rise to products. So type A is one that you have already seen that you usually use. Type B is something which is new. So for type B, won't I write this as, let's say initial concentration is A, this is B and this is 0. this will become a minus x, this will become b minus x, this will become x. Won't I write this? Okay, पावर ऑफ ए एंड बी आर, फर्स्ट इक्वेशन में dx by dt के साथ 1/2 मल्टीप्लाई नहीं होगा, बिल्कुल नहीं होगा प्रीतम, बिकॉज dx by dt tells us the change in concentration of products. Okay, change in concentration of products. So product initially is 0 and this is 1/2, product becomes 0 and this becomes x, so this becomes dx by dt is equal to k a minus x to the power 2. Now for this, can I say that the expression will be dx by dt is equal to k a minus x to the power 1 b minus x to the power 1? I will get this. Okay. Yes, I have to integrate both of them. Okay, I'll have to integrate both of them. Now for the first integral, if you do the integration for the first one like we have been doing until now, so अगर आपने first equation के लिए integrate किया, so you will get an expression like this. So for type 1, I'm just writing the final expression. For type 1, you will get the expression k is equal to xt and it will become how much? What will be the integral? This is 1 by u square. So what will be the integral for this? Thing is minus dt upon t square, minus dt upon t square, which will ultimately become equal to t to the power, t will become to the power minus 2 plus 1 by minus 2 plus 1. Okay, so this will be minus of t to the power minus 2 plus 1 by minus 2 plus 1. This will be 1 minus 1 minus 1 1 and this will be 1 by t. I guess you should get the answer. अरे ठीक है, वो बाद में आ जाएंगे उस पे. It will get 1 by t. So the expression will be like this. I'll get this thing as 1 by a minus x is equal to kt plus c. Okay, and for c, what will be c equal to? C will be equal to 1 by a, because how do we calculate c? At time equals to 0, x is equal to 0. So this will be 1 minus x minus 1 by a is equal to kt. So what will be the expression for k? K will be equal to x by at x by at a minus x. You will be getting this expression. Okay, you will be getting this expression. Is that clear? Now type 2 would be solved integral by partial fractions. I'll just give you the expression. Okay, so I hope this is clear. This is very, very simple. We'll use just this one to a greater extent, but for the second one, we would be getting this expression. For type 2, I'll be getting this expression. K is equal to 1 2.303 by b minus a times t log of B A minus X by A B minus X. Okay, I'll get something like this. Is that clear? Is that clear? Let's say we change this a bit. इसको मैं लिख देता हूँ A minus B okay, let's say we write this will be like A minus B. Okay, it will be like this. Now this is where things get little interesting. Suppose A and B are two reactants which are taken. A and B are two reactants which are taken. If this is A and this is B, this is the initial concentration. This is the initial concentration. If concentration of A is very large as compared to B, if concentration of A is very large as compared to B, can I say A minus B, can I say A minus B will be nearly equal to A times T? A minus B will be nearly equal to this. This will become A minus X will be nearly equal to A. So B times A by A B minus X. This will get cancelled, this will get cancelled. And if I rewrite this, B by B minus X. What does it resemble? What does it resemble? Doesn't it resemble the expression for the first order reaction? Doesn't it resemble the expression to calculate rate constant for first order reaction? Can I say this? Doesn't it resemble the expression to calculate the rate constant for first order reaction? Is this a first order reaction? No. But because of this scenario, because one of the reactant becomes very large as compared to the other reactant, the rate expression or the rate constant expression looks like first order reaction. So this is pseudo first order. Okay, this is pseudo first order. Okay, so we'll discuss this again in the next class. This is the last thing for today. I hope you enjoyed today's class and remember this remember this particular inference. We'll continue from here in the next class. We'll discuss nth order reactions and उसके ऊपर फिर question solve करेंगे. ठीक है? So this is Saurav Goswami signing off and please do join us in the next session because we'll be again continuing from here. ठीक है? चलिए, bye bye guys and have a lovely time.